All right, so now what we're going to do is we're going to take what we just learned about measuring an arc length, and we're now going to learn how to identify a radian angle measure, which we call theta. This is a Greek letter, theta, and theta is probably one of the most common symbols used to represent an angle measure. Now, when I say angle measure, you know exactly what I'm talking about. I'm talking about, for example, if we were dealing with some kind of triangle, okay, we might say the measure of this angle is, I don't know, 118 degrees. And the measure of this angle, let's call it x, and then the measure of this angle over here, we could call that theta. Okay, it's very common to use the Greek letter theta as a variable to represent an unknown or variable angle measure in a triangle, in a square, or what we're dealing with in this particular subject is, I'm going to draw a smaller circle here. We are going to deal with angle measures that start here and let's say go up to here. And what we're looking at is we have this radius, or we can call them line segments. And between the two of them is an angle measure, and we would call that angle measure theta. Okay? And we're going to talk more about that in a little bit. But what I want to do right now is I just want to use what we learned about arc measures, and I want to start with to identify the angle measure theta. I want you to understand that the angle measure theta always starts at this line right here, with this line. We're going to call that the initial side. Okay? So this line is called the initial side. And then what we're going to do is we're going to draw another one. We could draw it here, we could draw it here, we could draw it here. Basically, the idea is that this other side that we're going to draw starts here and it goes here, then here, then here. It circles around, it rotates around like a hand on a clock, but it goes backwards. It goes counterclockwise instead of clockwise. That side is called the terminal side, okay? And so let's say that we had a situation where we wanted to identify radian angle measure theta that starts here and ends right over here, okay? And so it's going to start here and it's going to go around over to here. Well, what we're going to do is we're going to use what we understand about the arc length to calculate the angle measure. Now, it is very likely that you have already learned in geometry that the degree measure of the outside of the circle is equal to the central angle that is created by that arc. So, this arc that starts here and ends here. From here, we will draw a line to the center of the circle, and from here, we will draw a line to the center of the circle. Okay? And now this line is called the initial side. The initial side is always the horizontal line that is to the right of the center of the circle. And the other line, we're calling that the terminal side. So we have the initial side and the terminal side. And here's what happens. Is starting above the initial side, not below the initial side. We're not going to draw the angle this direction. We could do that later, okay? But for the beginning here, we're going to start the angle above the initial side and we're going to curve it until we hit the terminal side. So I'm going to draw a little tiny curve here till it hits there. And that arc, that little curve there, is notation in math that represents angle, okay? And so this is representing an angle, and this right here is an angle, okay? And we're going to measure that angle not in degrees. We're going to measure that angle in a new angle measure called radians, the radian angle measure. So I'm going to take an aside just for a second in case you don't already know this. You know how you can measure things like, for example, here's a ruler. This is convenient that I have this right here. And this ruler is broken up into inches, right? 12 inches from here all the way over to here. But down here, if we flip it upside down, from here over to here, it's in centimeters. And we have 1 centimeter up to 30 centimeters. Now, 30 centimeters is not precisely equal to 12 inches, but both of them are very close. We know that we can measure things in inches, or we can measure them in centimeters. And so it's just 2 units of measure that can be used to measure the exact same thing. So I'm going to pick up an arbitrary object here. Here's a pen. If I were to measure this pen in inches, I would start it over here at 0 inches, and you would see it would go to about, it looks like we're at about 5 3/4 of an inch, okay, or 5.75 inches. But we could also measure the exact same pen in centimeters, and it looks like we're coming up at about 14.6 centimeters, okay, or 14 centimeters and 6 millimeters, okay. The pen didn't change. It's the same pen. The only thing that we changed is the units of measure. In the first one, the units of measure was inches, and in the second one, the unit of measure was centimeters. Well, it's the exact same thing here with the angle. You are accustomed to measuring angles in degrees. Most of the geometry that you have done up to this point has measured angles in degrees. All I'm telling you is that there is another unit in which to measure angles, and it is called radians. Now, we've been learning about radians in the last couple videos, right? Radians, you said, well, wait a minute, isn't radians the unit of measure where you measure the outside of a circle using the radius? Yes, and it's the exact same measure that is used to measure the angle. So in order to understand this angle measure, we are going to identify this angle measure based on the arc length on the outside of the circle when the radius is equal to 1. The radius has to be equal to 1. You can only do radian angle measures based on the arc length of the outside of the circle when the circle has a radius of 1. So this entire thing we're going to do, we are going to assume in all cases here that the radius is equal to 1. This is a circle that has a radius of 1. So now all we have to do to identify the radian angle measure of this particular angle is calculate the length of this arc, which we learned how to do in the last lesson, right? So first, we need the circumference of the circle. Okay, radius of 1, circumference of the circle is 2 pi. So circumference is 2 pi. Now we need the fraction of the arc length fraction of the entire circle. This one is broken up. We went back to 1, 2, 3, 4, 5, 6, 7, 8. And this arc length is 1, 2, 3 sectors, so 3/8. And now all we have to do is take our 3/8 and multiply it by 2 pi. So 3/8 times 2 pi is equal to 3 times 2 pi is 6 pi over 8. Now reduce the fraction. 6 and 8 can both be divided by 2, so we have 3 pi over 4. And so, here's what I'm telling you. 3 pi over 4 is the arc length, but it is also what we call the theta angle measure. This angle measure is 3 pi over 4 radians. And it would be the exact same thing as saying a certain number of degrees. And probably in the next video, we're going to look to see how we can convert between radian angle measures and degree angle measures. You're going to be an expert at going between radians and degrees to radians, okay? All right, let's do another one where we calculate the arc length and calculate the radian angle measure. Okay, so here's our arc length. We're going to go from here all the way around to this point right here. But we don't want to know, well, I do want you to calculate the arc length from here around to here when the radius is 1. But what I'm really interested in is what is the angle measure. Here's our terminal side. Here's our initial side and our terminal side. And like I said, the angle starts here and it comes around to here. We're not always doing the less than 180 degree angle. This can be larger than 180 degrees, but we want the measure in radians, okay? It's starting here and it's going above the initial side and around to the terminal side. Please identify the radian angle measure of this angle right here. Pause the video, go. Okay, so remember what we said is that the angle measure is equal to the arc length in radians, right? So, to identify the arc length in radians, we need the circumference. It's automatically a circle with a radius of 1 times 2 is 2, so the circumference is 2 pi. And I know what you're thinking, is it always going to be 2 pi when we're doing radian angle measures? Yes, it will. And now we need to know the fraction. We have 5 slices out of 8 slices, so our fraction is 5 out of 8. Now we just have to multiply 2 pi times 5 out of 8. So 2 pi times 5/8. 2 pi times 5 is 10 pi over 8. 10 and 8 are both reducible by 2. They can both be divided by 2. 10 divided by 2 is 5, so 5 pi. 8 divided by 2 is 4. And so the arc length is 5 pi over 4. And the angle measure, theta, is also 5 pi over 4. And so the answer here is theta is equal to 5 pi over 4 radians. Remember, that is, radians is an angle measure, just like degrees is, okay? All right, let's do one more example, and then we can move on to probably about the last topic that we're going to do. All right, now we're going to try one that has 12 slices. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We want to know radian angle measure theta of the angle created by the arc that starts here and ends here. So here's the idea. Now, I didn't do this in the last two examples because we're progressing little pieces at a time. So this arc length right here, this arc on the outside of the circle creates an angle from these 2 points. From that point and from this point, I want to draw a radius from that point to the center of the circle. So from here, I'm going to draw a straight line to the center of the circle. And from this point, I'm going to draw a straight line to the center of the circle. When I draw those 2 lines, this one is always going to be called the initial side, and the other one is always going to be called the terminal side, okay? And the angle created by those 2 radiuses, that angle is the angle that we're looking for. We're trying to find angle measure theta. And the way we're going to calculate angle measure theta is by simply calculating the arc length, which we know how to do. So, pause the video and calculate this arc length. Remember, the radius is 1. Okay, so we need first the circumference of the whole circle. Radius is 1 times 2 is 2. Circumference is 2 pi. Now we need the fraction of the arc length compared to the whole circumference. We have it broken up into 12 pieces, so it's out of 12, and we're only doing 2 sectors or 2 slices. So that's 2 out of 12. And now all we have to do is multiply 2 pi times 2 over 12. So 2 over 12 times 2 pi. 2 times 2 pi is 4 pi in the numerator over 12 in the denominator. 4 and 12 are both divisible by 4, so we can reduce this by a factor of 4 in the numerator and denominator. Divided by 4 means just pi, because it's 1. 4 divided by 4 is 1, so 1 pi. But when it's 1 pi, just write pi. Do not put 1 pi, just put pi. Okay? over 12 divided by 4 is 3. And therefore, the answer to this, the arc length, the length from here to here is pi over 3. And that means that the angle measure is also pi over 3. Okay? All right, so now what we're going to do is we're going to go, now that you understand how to calculate an angle measure, we're now going to understand how to convert between radians and degrees.